Hello students and welcome to my channel Maths Hub. So today in this video, I will be telling you about the solutions of heat equation. So let us first understand what is a heat equation, what is its mathematical modeling, and then we will go to the solution, right? So in a heat equation, what is the physical problem? You can see that we are taking a physical bar over here and this bar is having a length L, right? So we are keeping the ends, that means the point x equal to 0 and x equal to L at 0 degree temperature. And what are we doing? We want to calculate the temperature of this bar at any point T. So when we are keeping the ends at 0 degree temperature, so with time T, the temperature first it will initially start increasing, and by the time it reaches the other end, it will try to decrease, right? So that means with increase in temperature, the temperature of the bar is decreasing with time T. So the mathematical modeling of the problem is del U by del T is equal to C square del square U by del X square, right? So now with the help of this problem, we will be solving this equation. So, so we are into the equation del U by del T is equal to C square del square U by del X square, right? So you can see that. Let's understand what are these parameters. U is the temperature of the bar, T is the time T, and X is the length along the X axis, right? So what are the initial conditions to solve the heat equation? The initial conditions are, as we said, that U depends on X and T. We are keeping initially, that means at time T equal to 0, at the initial point, that means at X equal to 0, we are having the temperature of the bar equal to 0. That is the first condition. Then at the end point, that means at x equal to L also the temperature is 0. And the final condition ux comma t, that will be provided to you in the question. So with the help of that condition, we can solve any heat equation, right? So let us try to solve it. So we will use the method of separation of variables to solve the heat equation like we did for wave equation, right? So if you have missed out the video on wave equation, do watch that before you check the solution of heat equation. Method of separation of variables, right? So what happens in the method of separation of variables? We can see clearly that u is dependent on the two variables, that is x and t. So we assume that let u is equal to functions of x multiplied by t, where x is a function dependent on small x and t is a function dependent on small t, right? So what is del u by del t? Del u by del t will be x into t dash, and del square u by del x square would be x double dash t. So let us substitute the values in the given equation. So we get x t dash is equal to c square x double dash t. Now let's separate the variables as it is given in the question. So we will get x double dash by x is equal to, what will happen? We will get 1 by c square t dash by t. We can put it equal to some constant k. And now let us see that what can be the possible values of k. K can be positive, k can be 0, and k can be negative, right? So let's take up the first case when k is positive. So when k is positive, we can assume k to be p square. So let us put the first equation x double dash by x equal to p square. So when you frame the equation, you will get x double dash minus p square x square is equal to 0. So this implies d square minus p square x square. Sorry, it's x, it's not x square. I made a mistake over here. So d square minus p square into x is equal to 0, right? Okay. So from here, the auxiliary equation becomes d square minus p square is equal to 0. So when you convert it into algebraic expression, it becomes m square is equal to p square. So m is equal to plus minus p. So you can see clearly that the roots are real and distinct. So the solution x would be c1 e raised to power px plus c2 e raised to power minus p. Right? So this is the value of x. Now let us quickly calculate the value of t. So we have the other equation 1 by c square, t dash by t is equal to p square. So we get t dash minus p square c square, t is equal to 0. So from here we can write this as d dash square minus c square p square into t is equal to 0. So the auxiliary equation becomes d dash square minus c square is equal to 0. So the algebraic expression becomes m square minus c square p square is equal to 0. So m turns out to be plus minus cp. So what is t? T is c3 e raised to power cpt plus c4 e raised to power minus cpt. Right? So from here we can frame our u as c1 e raised to power px plus c2 e raised to power minus px multiplied by c3 e raised to power cpt plus c4 e raised to power minus cpt. Right? But what can you see from here? You can see that we have the physical problem as that with increase in time, the temperature should decrease. So you can see that it is not satisfying this condition. So we cannot assume this as our solution, right? So we move on to the second case. That means when k is equal to 0. So when k is equal to 0, your first equation will become x double dash by x is equal to 0. And the second equation will become t dash by t 1 by c square is equal to 0. So from here we will get x double dash is equal to 0. So d square x is equal to 0. So we will have d square equal to 0. So that implies m square is equal to 0 or m is 0 comma 0. So x comes out to be c1 e raised to power 0x will become 1, right? So I'm not writing that term. Then the next term will be x times c2. And here we will get t dash is equal to 0. So d dash into t is equal to 0. So we will get m is equal to 0 and t comes out to be c3, only c3, right? So what is your u? U is c1 plus x c2 into c3. So again, you can see that with increase in time, there is no factor of time coming in this expression. So obviously this cannot be the best possible solution, right? So let's move on to the third part. So the third part is when k is negative. So we will get the first equation as x double dash by x is equal to minus p square, and we will get 1 by c square t dash by t is equal to minus p square. So x double dash plus p square x is equal to 0. So we will frame d square plus p square into x is equal to 0. So that implies the auxiliary equation will become d square plus p square is equal to 0. So m square plus p square is equal to 0. So m comes out to be plus minus iota p. So what is x? X is c1 cos px plus c2 sin px, right? Now let's take the case of t. So we will get t dash minus c, it will become a plus here, c square p square t is equal to 0. So d dash plus c square p square into t is equal to 0. So the auxiliary equation will become d dash square plus c square p square is equal to 0. So your algebraic expression becomes, sorry, it's not d dash square. So the algebraic equation will become m plus c square p square is equal to 0. So this implies m is equal to minus c square p square. So from here t comes out to be c3 e raised to power minus c square p square t. So finally we get x u as c1 cos px plus c2 sin px multiplied by c3 e raised to power minus c square p square t. Right? Now, y is the best possible solution? You can see that t is carrying a negative sign. So with increase in time, what will happen to the temperature? It will keep on decreasing, right? So this becomes our best possible solution, right? Now, how to apply the initial conditions and to get the constants? Let's see in the next slide. So we got the best solution as u as c1 cos px plus c2 sin px multiplied by c3 e raised to power minus c square p square t. Now, what is the first condition? The first condition is initially, that means at x equal to 0, the temperature is 0. So let's put, that means we are putting the condition on x. So 0 is equal to c1, cos 0 is 1, sin 0 is 0, so c2 will vanish and we will get c3 e raised to power minus c square p square t. Now you can see that the condition is being applied on the variable x. So the part which is containing t is unaffected. So if this product is equal to 0, so this part will never become 0. So that means that c1 is always equal to 0. If c1 is equal to 0, let us reframe our u. U will come out to be c2 sin px multiplied by c3 e raised to power minus c square p square, right? Now, what is the next condition? The next condition is u at the other end. That means at x equal to L, the temperature is 0. So, 0 is equal to, let's put x equal to L. So, we will get sin PL C3 e raised to power minus c square p square t. Now, again in this part is unaffected because we are putting the condition on the parameter x, right? So, that implies that C2 into sin PL is equal to 0. But can C2 become 0? If C2 is 0, already C1 is 0. So the entire expression will become 0, right? So if C2 is not equal to 0, so C2 cannot become 0. So we will get sin PL is equal to 0. And which values of sin are equal to 0? Sin n pi. So from here we will get PL is equal to n pi. So what is P? P will come out to be n pi by L, right? So from here, let us reframe our U. U will come out to be C2 into C3. I'm writing the constants together. Sin PL, so sin PL is sin n pi. Then we will have C3 into e raised to power minus C square. P square is n square pi square divided by, sorry, this, we are putting it here. So it is sin n pi by L into x. We are using this equation, right? So we are putting P equal to n pi by L. N square pi square by L square t, right? So till here, any question on wave comes to you, you will solve till here ditto same, right? After this step, whatever is the next condition given to you in the question, accordingly, you will calculate the values of these constants, right? So till this step, everything from the very beginning to this step, everything would be same, right? So now let us see how the question will appear. So a rod of length L with insulated sides is initially at a uniform temperature U. Its ends are suddenly cooled to 0 degree temperature and are kept at that temperature. Prove that the temperature function uxt is given by this, right? So you can already see that we have calculated U as C2 C3 sine n pi by Lx into e raised to power minus c square n square pi square by L square into t, right? So C2 into C3 is a constant. So let us name it as Bn. So we will get Bn sine n pi by L into x e raised to power minus c square n square pi square by L square into t. Now, When we have this n is working for all the values of n, that is 1, 2, 3, and so on. So let us sum for all these values. So when we sum for all these values, we will get summation n going from 1 to infinity, bn sine n pi by lx into e raised to power minus c square n square pi square by l square into. So that is our required answer, right? So I hope you understood the solutions of heat equation, right? Okay. So let's look at this quick exercise. You have to find the solution of del square u by del x square equal to h square del u by del t, for which u 0 comma t and ul comma t are 0, ux comma 0 is sine pi x by l by the method of separation of variables, right? So the only difference that you can see in this equation is, if you compare heat equation, it is del u by del t is equal to c square del square u by del x square. So the first change is that c square has been replaced with 1 by h square, right? So wherever in your question, in your solution, you are getting c square, you will replace it with 1 by h square, right? That is the first change. Then after putting the first and the second conditions, that will remain same. So you will put the next condition, you were getting u as c2 c3 sine n pi by Lx into e raised to power minus c square n square pi square by L square t. So in place of c square, you will put 1 by h square, and then you will put this condition, put t equal to 0. You will have sine pi x by L, that will be equal to C2, C3. When you put t equal to 0, this term will vanish and you will have sine n pi by Lx, right? So when you compare, C2, C3 will come out to be 1 and n will come out to be 1, right? So you can put it back in this expression and u will finally come out to be C2, C3 is 1, n is 1. So it is sine pi x by L into e raised to power minus 1 by h square. N is 1, so you will have pi square by L square t. So this will be the value of your heat, right? The solution of heat equation. So I hope the solution is clear to everyone. So it needs a practice because it's lengthy, but it's not difficult. If you remember the steps, what we are doing, you will be able to grasp the topic, right? So thank you so much for listening to me. Those of you who haven't subscribed my channel, do subscribe my channel to get the latest updated video. And those of you who like the video, do hit the like button and have a nice day and believe in yourself.